All right, something else that we need to touch base on is angles of elevation and depression, and understanding what angles of elevation and depression are. So remember that angles of elevation and depression, they're always measured by looking out to the horizontal. So wherever you're starting from, all right, from is a massively important word. Wherever you're starting from is where you look to the horizon, and an elevation is when you look up, and depression will be then obviously when you look down from that horizontal line that you're looking from. And we know the saying, a picture tells 1,000 words. And when it comes to any kind of trigonometry, I can't recommend highly enough that the first step to answering the question is to have a good diagram, a good picture of what's going on. Cool. And the other thing that we need to know and we need to think about is, because two horizontal lines are always going to be parallel to each other. If two lines are horizontal, they will always be parallel because they're horizontal. So we need to drag up those memories from Year 7, Year 8, Year 9 of all the angle properties around parallel lines as well. And there's just some really bad drawings of eyes talking about elevation looking up from the horizon and depression looking down from the horizon. Cool. And I can't stress enough to lock away in your memory bank that two horizontal lines are parallel to each other. All right, so jumping into two examples on angles of elevation and depression. All right, so the angle of elevation of a tower was measured at 32 degrees. So what's important to understand there is that we've got this word elevation. So the angle of elevation, that means so someone was looking out to the horizon and then looked up to the top of a tower, and that looking up part was 32 degrees tall. We know that the tower is 103 meters tall. All right, cool. How far away from the base of the tower was the measurement taken? Answer correct to 1 decimal place. Right, so using our information, what we're going to do here is we're going to draw a picture. It doesn't have to be anything fancy. So there's my tower, that's 103 meters tall. We know that somewhere along the base, someone was standing on the base, and that angle there was 32 degrees tall. And you're asked to find how far away, so we're asked to find the distance, so we're asked to find that measurement there. Now, if we go back through the question, nowhere in the question does it say that the tower is perpendicular or at right angles to the ground. That's just assumed in these questions, that unless we're talking specifically about the Leaning Tower of Pisa, the absolutely majority of buildings are built perpendicular to the ground, built at right angles to the ground. So unless the question says the building isn't at right angles, like the Leaning Tower of Pisa, just always assume that the building is at right angles. All right, so if we have a look at this one, going through, I've got the opposite and the adjacent side, so that's going to be tan. So I'm going to have tan of 32 degrees is equal to 103, opposite over adjacent. I'm going to slide this over to give myself some more room. X is going to equal 103 on tan of 32. So X will equal, and we asked to 1 decimal place, yeah, 164.8. So again, I ran out of room, so I'm just going to move that up there to give myself some more room. X equals 164.834 dot dot dot. So it's going to equal 164.8 meters. Example 2, I've actually taken this example straight from a general mathematics HSC from a few years ago. So here we can see it's a multiple choice question, and the angle of depression from a kookaburra's feet to a worm on the ground is 40 degrees, and the worm is 15 meters from a point on the ground directly below the kookaburra's feet. So if we just break that down, this directly below the kookaburra's feet, that part of that sentence there, it just confirms that we have a right angle triangle. So from the worm to directly below, due south, if you want to call it, of the kookaburra's feet, it is 15 meters. There's our right angle. All right. There's a couple ways we could tackle this question. One thing to remember is that all horizontal lines are parallel to each other. And because all horizontal lines are parallel to each other, our rules about parallel lines come into play there. So hopefully you can see that there's that Z shape forming there. And because we've got a Z shape, that it is also 40 degrees inside there because they are alternate angles. And what we're asked to find is the height up there. Now that we have that, we've got a number of different ways we can now just go through and solve it. In a different color, let's go purple. If you didn't want to play with alternate angles and parallel lines, what you could do is put that in there, that we know that that triangle, it can be reflected up, and then that is also 15 meters, and there's 40 degrees. So you've got two different triangles. If you wanted, you could play at. So if I was to use the purple, 40 degrees is the opposite, x, sorry, is opposite 40, and 15 is adjacent. So tan of 40 degrees is equal to x on 15, which x then becomes 15 times tan of 40, which becomes 12.5, which equals 13 meters. If I followed the alternate angle and I did it in blue, well, the blue part, x is my opposite and 15 is my adjacent. Look, I'm going to get the exact same answers there as well. One final thing you could have done, and I don't want to overload you with this question, but if there's a right angle down the bottom, because horizontal lines are parallel to each other, we have a right angle up in the top, which means it's not 30, you goose, that it's 50 degrees inside there. And that's just complementary. 50 plus 40 has to equal 90. And now that you have a 50 degrees inside the triangle, you didn't need to worry about that 40 down the bottom, and you could use 50 degrees to go and solve it. Multiple ways to attack the same problem, all will get you to the exact same answer. Did that confuse anyone by adding all those different lines and bits of information in? The last part where I put the 50 degrees in rear? Yeah. So what we can think of is, are you comfortable that up the top there is a right angle? Yep. Because it's a right angle, that right angle is split into two sections. We know 40 degrees. That means the other part of that right angle there has to be 50 degrees. And now that we know that that's 50 degrees, we don't need the 40 degrees down the bottom. We could say, well, x is the adjacent side, 15 is the opposite side. So you could have done tan of 50 degrees equals opposite over adjacent, which equaled 15 over x, and then carried on our working that way. Just another way of doing this. Either way, we had to form a triangle with an angle and make a reference to an angle. We could have done the 40 degrees, or we could have manipulated using complementary angles and done 50 degrees. So our answer was C, 30 meters.